Okay, if you're watching this video, that means that you have just completed this lab with these special segments, and you should have received these notes, which is what we need to go over. So the first thing that we need to talk about is concurrent lines. Concurrent lines or segments are three or more lines that intersect at the same point. So again, up here you need to write three or more lines that intersect at the same point. The point of intersection where the concurrent lines meet is called the point of concurrency. So it says every triangle has special segments: medians, altitude, perpendicular bisectors, angle bisectors, and each set of segments has its own corresponding point of concurrency. So the first one that we're going to talk about is the segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. In other words, it's drawn from a vertex to a midpoint of the opposite side. So if you go back to your lab, here's the triangle that we're looking at. It's supposed to be drawn from a vertex. Well, I don't have anything drawn from A. I don't really have anything drawn from B, but I've got two lines that are drawn from C, the altitude here and the median. Well, it says it's supposed to go from the vertex to the midpoint. So that would be this blue line right here, and it's called the median. So the median is the segment that starts from the vertex to a midpoint of the opposite side. So what we could do is actually find the midpoint of PR. So if you get kind of a ruler, oh, I'm in centimeters. So this is about 2 inches, maybe a little bit short of 2 inches. So this is the approximate midpoint. So if I draw this here, I can call this M for midpoint. And the median goes from the vertex here to the median here. So things that we need to talk about. Oh, I just did all that and you couldn't see it. Sorry. I meant to move it up. Okay, so again, I found the midpoint, which was about 1 inch or so, and then I drew a line from Q to M. So things that we need to talk about is, does the median have to be perpendicular? So if I look up here at our picture, does this look like two right angles? It certainly doesn't look like it. So we would say it does not have to be perpendicular. Okay. Just so you know, every triangle does have 3 medians, because I could measure and I could find the midpoint of QR just as well. And then I could draw from P to that midpoint, and that would still be a median. So then of course I could do the same thing for Q to P. And then I could draw a line from R to the middle of that line as well. So there is all 3 medians. So the point of concurrency, meaning where all 3 of these lines meet, is right here in the middle. And this point of concurrency is called the centroid. Okay? And the centroid, which is the point that we're talking about, is 2/3 of the distance from each vertex to the midpoint. So if you notice this line right here, this is 1/3, and then this side is 2/3. So if we broke this down into sections, it'd be here, the point, and this point. So you've got 3 pieces, and 2/3 of it is on one end. Same thing here, 1/3, and then 2/3, 1/3, and then 2/3. Okay? And then the last thing that you need to know about the centroid is that it is the center of gravity. So if I were to take that triangle and spin it or try to balance it, the centroid is the spot where I could get that triangle to balance. Okay, so the centroid is the center of gravity. And again, that is the point of concurrency for the medians. All right. So now let's look down here at the next one. The next segment that we want to talk about, it says the endpoints are a vertex of the triangle and a point on the line containing the opposite side so that the line formed is perpendicular to the opposite side. So the easy way to say that is in parentheses. It's drawn from a vertex, but it's perpendicular to the opposite side. So if we go back to our lab, we're going to go back to what we were talking about before. It has to go from a vertex, C, but it's got to be perpendicular. So that's our pink line, which we wrote down was our altitude. So the altitude, which is a fancy word for the height, so if you need to write that down, maybe out here you could put that it is also the height of a triangle. Okay. So if we wanted to draw the height, it has to go from the vertex so that it creates a perpendicular line. So I'm going to scoot this up just a little bit. So I want to try to make the best right angle I can. So we would draw from Q straight down so that this is perpendicular. Again, remember, perpendicular means that it equals 90 degrees, or it forms right angles. So we've already discussed this, but altitudes do have to be perpendicular. That's what we just talked about as the definition. So they do have to be perpendicular. Okay. Every triangle does have 3 altitudes. And the point of concurrency for the altitudes is called the orthocenter. And then for something that you need to know is if we do have an obtuse triangle, the orthocenter and 2 of the altitudes will actually be outside of the triangle. So we can kind of maybe draw a obtuse triangle out here off to the side. And if you notice, if we were to draw here straight down so that it was perpendicular, we would have one here. But then to go from this vertex straight down, we would actually be outside the triangle, out here. Okay, so that's what they mean. All right. Go ahead and flip your notes over. We're going to move on to the next segment, or special segment. This segment is perpendicular to the side, and it cuts it into 2 equal parts. This should be a huge reminder to you guys. We've talked about this several times. 2 is bi, cutting is to sect. So cutting into 2 equal parts is bisect and perpendicular. So if we put it together, we're now discussing the perpendicular bisector. So by definition, it's going to form right angles, and it's going to cut one of the sides into 2 equal pieces. So, let's see. Not quite sure how to draw this one. But we can go back to our lab. Notice perpendicular bisectors do not actually start from a vertex. So it's just going to be drawn so that it literally divides and goes to the midpoint of one of the sides. So let's say that this is pretty close to the midpoint. It would be the line or the ray or the segment or whatever that would come straight through that point. Okay. This would be congruent to this, and then it would create a right angle on both sides. So since it's called a perpendicular bisector, it does have to be perpendicular. So this is that they do have to be perpendicular. Same thing, every triangle will have 3 perpendicular bisectors because you can do one from every side. So here is approximately a midpoint. Might be a little off. And then perpendicular so that this creates a right angle. And now we have this equal to this. And then we could do the same thing on this side. And now we would have this equal to this, and we would have a right angle. So if you notice, we do have a point of concurrency. Your point of concurrency for a perpendicular bisector is called the circumcenter. And the circumcenter is always going to be equidistant. And that should be a familiar, equi meaning equal, distant meaning distance. So it's going to be an equal distance from all 3 vertices. So if I were to measure, and it may not be too accurate because I just drew random, but it's approximately an inch from here, an inch from there, and then if I measure it from here to Q, it should also be an inch. So if you notice, it is equidistant from all 3 vertices. Okay. All right. Let's look at another special line. This is one that we should be kind of familiar with. We're still talking about the word bisect. So it's a segment that bisects an angle. So kind of an easy one to pick out. This is an angle bisector. And again, it's a line or a segment or a ray that cuts the angle in half. And then any point on the bisector should be equidistant from all the sides of the triangle. So again, when we're talking about an angle bisector, these do not or does not have to be perpendicular. But we will still have 3 angle bisectors. And this time the point of concurrency is called the incenter. And what we just talked about is that the incenter is equidistant from all 3 sides. So again, this is going to be very difficult to kind of draw, but we can attempt to try to cut these angles into 2 equal pieces. I'll see if I can draw it on here. So there would be that one. I'm a little off, as you can tell, because I didn't quite get the right angle there. And this one. And possibly this one. So again, ooh, I did real bad on that one, but this should be equal to this if I did it correctly. This one should have been equal to this one. And then over here, this should have been equal to this. That's probably the closest one that I got to. But then this point right here would be the in-center, and it should be equal distance from all three sides. So if I were to measure to here, and then this way, and then that way. But obviously, since I messed this one up, it's not really going to work too well. All right. So the last thing that we need to talk about, it says the segment whose endpoints are midpoints of the two sides of a triangle. And it says this segment will be parallel to the third side, and it will be half the size. And this is called a mid-segment. Or on your lab, we called it the segment that connects the midpoints. It was the green line on your lab. Okay, so right here. So if we were to draw a mid-segment, we would find the midpoint of PQ. We would find the midpoint of QR. And then we would connect those two midpoints. And what that means is that if this was 10, this is 5, because halfway up means half the size. Okay. And then again, we could do the same thing down here. And we could have 3 mid-segments, because we could put one here, and we could put one over here. So this one would be half the size of QP. This one would be half the size of QR. So it's whatever they're parallel to that they are half the size of. So again, it does not have to be perpendicular. Every triangle will have 3 mid-segments. And mid-segments do not have a point of concurrency, because obviously they don't all intersect at the same spot. So based on this information, I want you to try to label these pictures down here and see which special segment we're talking about.